Hello once again. Welcome to another episode of THP Tutorials. I'm Seth, and in this episode, we'll be looking at the sixth chapter in Management Accounting, Management Information Systems, and that's Foundations of Business Intelligence, the databases and information management, right? So, databases and information management are the foundations of business intelligence. If you don't know what business intelligence is, you can just check out the first chapter and you'll be all right. So before we begin, kindly hit the subscribe button and drop a like. These are the objectives, right? In the course of this chapter, we will learn the problems that come with managing the data resources in a traditional file environment. We'll look at the major capabilities of database management systems, that's DBMS, and why relational database management systems are so powerful. Right. So database management systems came after the traditional file management system. So here saying that the traditional file environment, that's what was used before database management systems came about. We also look at the principal tools and technologies for accessing information from databases to improve business performance and decision taking. We're also going to look at the why information policy, data administration, and data quality assurance are essential for managing the firm's data resources. So before we begin with all that, let's talk about some technologies that we'll be using throughout this chapter. Right, it's very essential for us to understand these technologies because understanding them will help us understand everything. So first of database. Now I say the database is a group of related files. A file is then a group of records of the same type. Then a record is a group of related fields. And a field is a group of characters, as words or numbers. Now a field describes an entity, right? An entity being the subject of information, right? Or the person, place, or thing on which we store information, right? Now the attribute is each characteristic or quality describing the entity, right? So attributes like date or grade belong to the entity code. So what we are saying is that with fields, they are broken down into entity and attributes, right? So entity is basically like your name. Imagine if you had a file of boys in your class. You probably have the index number of each boy, or you could use a name. So their name would be the entity, would be in the entity column. And then the other columns or field, no one say field is column. The other fields would have maybe height, skin color, weight, among other or any qualities you want to add to your file. We'll talk more about all these things as we are progressing. Now, let's talk about the data hierarchy, right? How is data ranked? So a computer system organizes data in a hierarchy that starts with a bit, right? And a bit represents a 0 or a 1. Bits can be grouped to form a byte to represent one character or number or symbol. Bytes can then be grouped to form a field, and related fields can be grouped to form a record. And related records can be collected to form a file, and related files can be organized into a database. Right, so that's just an explanation of the diagram that I see here. Right, so you have the student database, right? So where does it start from? You have the bit. Remember, it's a 0 or 1. So 0 or 1, that's a binary code. That's a language that computers speak, basically. Right, so this ASCII, it's a coding language. So we have a byte. It can either be a 0 or a 1. When you put bytes together, you can use them to represent one character. That character could be a letter, a number, or a symbol. So byte for in, so here you have a byte, right? And you're seeing the combinations of the zeros and ones. 0100 1001. Right. So in the coding language, the ASCII coding language, that's referred to as. So that's how I is represented in that coding language, right? So this means that when you type in a message and you type on I, the computer does not interpret it as I the way you do. It is inputted into the computer as 0100 1001. Very well. So from the byte, when you put letters together or numbers together, you can get a field. Right now, this field is where you have the IS101. That's the course field. So when I was saying that the field is a column. So when you put related columns together, you can get a record. When you put related fields together, you can get a record, right? Now let's see this. So you see that this is the record, right? Student ID is a field, course is a field, date is a field, grade is a field. What we were talking about earlier, fields have entity and an attribute, right? So the student ID is the entity, right? That's the identification or the name of the person, place, or thing that we are getting information about. So this is a column and this is the entity, the first one. And then the course is an attribute. The date is also an attribute. The grade is also an attribute, right? Now when you put all these fields together, you want to have a row or a record. So that's student ID 39044. Course is information systems 101. That's the course field. And the date is what? L06. And then the grade is B plus, right? So this row here like this is forming a record. Because one field, two field, three field, four fields come together and you have a record. Let me try and illustrate that further. So you see, alright, so this is the record. This is the field, another field. Alright, now when you put related files together, you get database. So this is student database. This is a course file for students. This is a personal file. This is a financial file. Right. So that's what goes into this basically. So that's a hierarchy of data, or the data hierarchy. It starts from the bit, moves to the byte. You come to the field, you have the record, you have the file, you have the database. Now managing data in a traditional file environment, right? So this is the first objective that we talk about. So some of the problems are data redundancy, right? That's when data is duplicated in multiple files. So you just keep seeing the same data over and over and over again. Now data inconsistency, this is the same attribute as. So the data inconsistency, right? So this one, you see the same attribute has different values. So you keep seeing an attribute for an entity and it keeps varying. This is because what? The files are maintained separately by different the files are maintained separately by different departments, right? That's why. So with that, the data is inconsistent. And then the program data dependence, right? There are certain software programs that when you are using, they will alterate the information that they can access. So that's a problem with the traditional file environments. And there's lack of flexibility, there's poor security, and there's lack of data sharing and availability. Right, so this is what the traditional file processing environment looks like. Right, so the use of a traditional approach to file processing encourages each functional area in a cooperation to develop specialized applications. Right, each application requires a unique data file that is likely to be a subset of the master file. Now, these subsets of the master file lead to data redundancy and inconsistency, processing inflexibility, and wasted storage resources. So let's just break break this down, right? So you have this one department, another, and another, right? Accounting and finance. These are the users. Now, since everything is separate, everyone has to develop their specialized application program, which will use special information. Now, all this information is coming from this thing as well. This is the master file data element. So this is where all the information that they're accessing is A to Z. Everything is over here, right? In this tank. So accounting and finance will go and take the files that they need. Right? So we've taken A, B, C, and D. Human resources took A, B, D, A, B, E, D, A, E, F, right? So that's that A is running through that. That's the data redundancy that I'm talking about, right? Now A here, A here, A here, A here. This is just occupying space, and it doesn't need to be so, right? So this is what we are speaking about. The data redundancy, data ends up being inconsistent, and this application program can also alter some of the information inside. So these are the problems involved. So this is just the illustration of what the traditional file environment looks like. Well, so we're speaking about the problems over here, right? Yeah, we've done that. So moving on, we'll speak about the capabilities of database management systems, right? DBMS. So a database management system, you can say that before we define that, what a database is what? A database is a group of related files. Well, so it said that the database serves many applications by centralizing data and controlling redundant data. Right, so it centralizes data. So you just have one central access point. All the data is over there. Every department's data, everyone's data is over there. Right, so now database management systems, that is DBMS. We have interfaces. So the DBMS. So we know what database is now. What's a database management system? Now, a database management system simply interfaces between applications and physical data files, right? It separates logical and physical views of data. It solves problems of traditional file environment, right? So it controls the data redundancy, it eliminates inconsistency, it uncouples programs and data, right? So now the application is different, and then there's physical data is also different, and the DBMS is an interface between them. So it's kind of like a go-between. Can access from here, go to this people, take from here and go to, right? So it's so the program cannot alter the data. It enables the organization to centralize to central manage data and data security. So it also provides security for the data. So this is human resources database with multiple views. So this is what the DBMS does. Here I have the human resources database. Let's do this first. It says a single human resources database provides many different views of data, depending on the information requirements of the user. Illustrated here are two possible views, one of interest to a benefits specialist and one of interest to a member of the company's payroll department. Right, so this is a payroll view, this is the benefits view, data management system, right? So you don't need to have benefits department, then you have their own application program, then you have a payroll system. No, you just have one database for everything, every information that you need over there. So when you come to the database management system, you key in your requirements. So for a benefits view, you need the name, you need the SSN, you need the healthcare. So it just fetches this information for you, and you can do your work. So too for the payroll system, right? Name, SSN, your gross pay, your net pay, then you get information. You don't need to have every organization having its own application program, having its own derived files. Everyone just goes to the database management system, and information is given to them, right? Very well. So bear in mind, we've not started speaking about the capabilities yet. Right? It's all about capabilities. We're just having general information. That's what they want to be understanding, right? You can talk about what a database can do without talking about what a database is. So relational database management systems. So this is you see with the database management system, the DBMS, they can either be two, right? You can break them down. Break the diagram. You have the relational ones. Let's say right. So you have relational, then non-relational. Let's talk about the relational now. So with this one, it represents data as two-dimensional tables. Each table contains data on entity and attributes. For this, speaking about what these things mean. Table, so the table is a grid of columns and rows, right? So the table is a grid of columns and rows. So in relational database management systems, rows are also referred to as tuples. Yeah, and those one they have records for different entities. So the tuples have records for different entities. In, and the fields, which are the columns, they represent attributes for entity. So they represent the attribute for the entity. Now the key field is a field used to uniquely identify each record. Right? So it's usually the first one. We'll explain more. And the primary key is a field in the table used for key fields. Right? The primary key is a field in the table. It is used for key fields. Now the key fields are the fields used to uniquely identify each record. So the primary key is that field, that column in the table. Now the foreign key is a primary key used in second table as lookup field to identify records from original table. I will get into that eventually. Right, so a relational database organizes data in the form of two-dimensional tables. Illustrated here are tables for the entities, the supplier and parts, showing how they represent each entity and its attributes. Supplier number is a primary key for the supplier table and a foreign key for the part table. Right, so this is a supplier, this is a part, right? So this is a key field. This first one, this is a key field. We have the supplier number. And what do we say the key field was? It's the field that uniquely identifies each record. Let's come back. It's just to uniquely identify each record, right? So what remember I was saying it's a column. You'll see the key field. So supplier number 8259. So this is the record for that supplier. Here you have the supplier's name, the street, the supplier city, supplier state, OH, and the supplier zip code. Everything. So this is the information for the supplier. So the first one is the key field. So I was saying so you see columns, you have attributes of field. So one field, field. So the rows, these are the records or the tuples. Oh, I hope you are getting it. It. Now this is the second table. You have the part. So the part now. So this is the primary key or the key field for the parts. So the same thing, right? But now I have a foreign key. So let's come back. What the reason the foreign key was? It's a primary key used in the second table as lookup to identify records from the original table, right? So this foreign key is simply identifying that what for part number 1375, the door latch at a unit price of $22. They want to get that from supplier 8259. So this is the foreign key, which is a primary key being used in the second table to what as a lookup field to identify records from the original table. So you know that this record belongs to this supplier 8259, right? So that's very clear. So how does a relational database management system operate? There are three basic operations used to develop useful sets of data. So the first is that you select. That's why you create your subset of data of all records that meet the stated criteria. And so you create your subset of data of all records that meet the stated criteria. Then you join. You combine the relational tables to provide a user with more information than available in individual tables. Then a project. They create subset of columns in table, creating tables. Then a project it creates a subset of columns in a table, right? And that creates tables with only the information specified. So let's look. So here you have the part, right? The select part. So it says select, join, and project operations enable data from two different tables to be combined and only selected attributes to display, right? So this is the first table, this is the second table. What do we do? We create subset of data of all the records that meets the stated criteria. So see here, you select part number 137 or 150 over here. So I'm looking for this first one or this one. Very well. And you see that this is the foreign key over here, clearly specifying that what this 8259 and supply number 8263 is what we need, right? So you see that the arrows, you see that the arrows have been see this arrow is coming from here, this is also coming from here, so too for this one and this one, right? So then the part number 137 or 150, those are the subsets. So we create subsets of data of all records that meet the stated criteria. So we know what we're looking for, right? So we have our criteria. So we want the door latch and then the door mode. So we just select 107 or 150 because we need information from here and here. Then we join them. What they're joining. So the next we combine the relational tables to provide the user with more information than available in individual tables. So we combine the part table and the supplier table. We combine them, and then we project what we are looking for. So the selected columns that we choose will be presented, right? It's all part of the criteria that you choose. So you see, it creates subset of columns in a table, creating a table with only the specified information. So there you go, right? Select, join, and project. Right, so what are non-relational databases? That's a NoSQL or NoSQL. Right, that's with that one. With the non-relational databases, they are more flexible as a data model. The data sets are stored across distributed machines. They are easier to scale, and they handle large volumes of unstructured and structured data, right? From the web, social media, and even graphics. Very well, right. Now we have databases in the cloud as well. These are not necessarily a type of database, but it's a way of storing a database or managing it. So typically, they are less functional than on-premises database systems, right? So Amazon Relational Database Service, Microsoft SQL as your private cloud. So these are all databases that operate in the cloud. Well, so now looking at the capabilities of database management systems, right? So you have the data definition capability. With that one, it specifies the structure of data of the database content, and it is used to create tables and define characteristics of fields. Right. There's also the data dictionary, which is automated or manual file storing definitions of data elements and their characteristics. The data manipulation language, it is used to add, change, delete, and even retrieve data from the database. So with database management systems, they have data manipulation language, which enables them to add, change, delete, or retrieve data from the database. So the languages are like, you have the structured query language, this is the SQL, and then Microsoft Access user tools for generating SQL, right? There are many database management. So many of the DBMS have report generation capabilities, which they can use to create policy reports. Right. So one definition is the definition capability, data dictionary, data manipulation language, and then the report generating capability. So this is what the Microsoft Access Data Dictionary looks like. So let's skip this one. So figure 6.6. We have Microsoft Access, right? Microsoft Access is part of the Office suite, and it's a database management system. So it has rudimentary data dictionary capability, and that displays information about the size, format, and other characteristics of each field in the database. Displayed here is in the information maintained in the supplier table. The small key icon to the left of the supplier number indicates that it is a key field. Right, so now this key is indicated that this is a key field. So this is the dictionary. Alright, so this displays information about the size. So you have field size, format. So these are the information I'm talking about. The rudimentary data dictionary capability displays information about the size, format, and other characteristics. So these are the characteristics that we're talking about. So this is the same information that was in the supplier table that we just looked at. Well, illustrated here are the SQL statements for query to select suppliers for parts 137 or 150. They produce a list with the same results as figure 6.5, which was this one. This figure. So if you use that SQL language, you get this result. You select part number, part dot again, part name, supplier. So this is how you get the subset of the folders. Well, so here is an access query. Illustrated here is how the query in figure 6.7 would be constructed using Microsoft Access Query Building tools. It shows the tables, fields, and selection criteria used for the query. So for the part number, this is the selection criteria that we went with. For the supplier, this was where the key fields are, part number, and supply number. So this is a key field. This is a key field. There are some part name here, supplier number, supplier name. Exactly. So this is how it looks like when you are inputting this instruction. This is the result that you get. Another capability of database management systems is designing databases, right? You can use the DBMS to design a database. So how is that done? There's a conceptual or logical design that uses an abstract model from business perspective. Then there's also the physical design, which is how the database is arranged on direct access storage devices. So you make the conceptual or logical design, from the perspective of a business. And then you also have the physical design. That's how the database is to be arranged on the direct access storage device. Now with the design process, it identifies what the relationships among the data elements, redundant database elements. So the relationship among the data elements and the redundant database elements. The most efficient way to group data elements to meet business requirements and the needs of application programs, right? So the process of designing identifies two things. The first thing is that it identifies the link between data elements and then the redundant database elements. One. The second is that it identifies the most efficient way to group data elements to meet the business requirements and the needs of application programs. Right. Now you have the normalization. Now that's the streamlining complex groupings of data to minimize redundant data elements and awkward many-to-many relationships. Right. What does this mean? Let's break this down. So with normalization, it deals with when you have the complex groupings of data. So you streamline these complex groups of data to minimize the redundancy of the data elements and the awkward many-to-many relationships. So before normalizing data, that data is normalized. So this complex groupings of data are referred to as unnormalized data. So you have to normalize it to minimize the data redundancy and the awkward many-to-many relationships. So over here, this is a complex grouping of data, or a complex grouping, right? An unnormalized relation contains repeating groups. For example, there can be many parts and suppliers for each other. There is only a one-to-one correspondence between order number and order date. So this is the order number, order date. You have part number, part name, unit price, part quantity, supplier number, name, supplier street, city, supplier state, supplier zip, right? So how do we normalize this data? See, so we streamline it. So when we normalize it, so order is like, so you see that this order is a key. You have part number, part quantity. You have the part number here like this, part name, part unit price, and then supplier name. Then what do we do? We have the supplier name, is the number, the supplier's information. This is how you are normalizing it. Then you have the order number, the order date. So after normalizing, the original relation order has been broken down into four smaller relations. The relation order is left with only two attributes, and the relation line item has a combined or concatenated key consisting of other number and part number. Other number and part number. Right. So this one that it says it's combined. They've combined the other number and the part number as one. So now those two fields are the key fields. So back on with the capabilities of database management system. DBMS have the ability to use, well, in specific relational database management systems, use what the referential integrity rules to ensure relationships between tables and to ensure that the relationship between tables remain consistent, right? So that will is how it solves the issue of data inconsistency. So in relational database management systems, we use the referential integrity rules to ensure that the relationships between the tables remain constant. There's also the entity relationship diagram, and this diagram is used by the database designers to document the data model. It also illustrates the relationships between the entities. Caution: if a business doesn't get data model right, the system won't be able to serve the business well. So the data model is essential. And to get it right, use the database designers use the entity relationship diagram to document the data model, and that also illustrates the relationship between the entities. So this is an entity relationship diagram, right? So now this is the supplier, this is the part. The supplier provides the part, and the part is supplied by the supplier. The part is ordered. And so you're on a line item, right? So you order the parts to the line item, right? So the line item contains the part, and then the line item belongs to the order, or the order includes the line item. Right, so the diagram shows the relationship between the entities, supplier, part, line item, and order. That might be used to model the database in Figure system. All right. So now we are on our third objective, right? That's talking about the tools for improving business performance and decision making. So big data, right? You have big data. Big data, that's the massive set of unstructured or semi-structured data from web traffic, social media, sensors, and so on. There's the petabytes, you have the exabytes of data. The volumes to big data is just massive sets of unstructured, semi-structured data from web traffic, social media, and sensors, so on. They can reveal more patterns and anomalies. Right? Companies analyze big data to get key information on how they can improve, right? And that information serves as a competitive advantage. So other tools are business intelligence infrastructure. Today includes an array of tools for separate systems and big data. So IT infrastructure, that's the business intelligence infrastructure. We did that in week what? Week 5. So that's contemporary tools. So these are the tools that can be used to improve the performance of the business and also to improve the business's decision making. Data warehouse, data mart, Hadoop, in-memory computing, and analytical platforms. So what's a data warehouse? A data warehouse stores current and historical data from many core operational transaction systems. It consolidates and and standardizes information for use across the enterprise. But data cannot be altered. It provides analysis and reporting tools. And data marts. That these are a subset of data warehouse. The data marts are summarized or focused portion of data for use by specific population of users. Typically, data marts they typically focus on a single subject or line of business. So the data marts they have a single subject. Right? It's like focusing on something in particular. But the database is overall everything, right? That's a data warehouse. So this is a contemporary business intelligence infrastructure. So this is like contemporary means modern. So what's new right now. So currently, so the current business intelligence infrastructure looks like this, right? It features capabilities and tools to manage and analyze large quantities and different types of data from multiple sources. Easy to use query and reporting tools for casual businesses for casual business users, and more sophisticated analytical tool sets for power users are included. Right. So this is a data. You have operational, historical, machine data. Right. This is a Hadoop cluster. We'll talk about what these things are as we progress. So extract, transform, load. This is a data warehouse. This is a data mart. Right. So casual users, but the power users access everything from the data warehouse, and they can also use the Hadoop cluster for access, or they can just use the analytical platforms. The power users, use them for queries, reports, OLAP, and data mining. But the casual users, they also use for queries, reports, and dashboards. So this is like a typical setup of a business intelligence infrastructure, currently. So the Hadoop cluster that we saw, what's Hadoop? Right? Hadoop enables distributed parallel processing of big data across inexpensive computers. What are the key services that Hadoop offers? There's a Hadoop distributed file system, that's the HDFS, that's data storage. Then you have the MapReduce, which breaks data into clusters for work. Then the HBase, that's a NoSQL database. Now this Hadoop is used by Facebook, Yahoo, and NetBio. This is a Hadoop cluster. We'll just talk about that, right? There is enables parallel processing of big data. You see, everything is connecting to it. So it's processing everything at once and sending them to the data warehouse, also sending them to the analytical platforms, also serving directly to the power users. Right? Exactly. So another tool is the in-memory computing. That's used in big data analysis. It uses computers' main memory, that's RAM, for data storage to avoid delays in retrieving data from disk storage. It can reduce hours or days of processing to seconds, and it requires optimized hardware. So the in-computer processing is used in big data analysis. So the in-memory computing, it uses computers' memory, that's the RAM, for data storage to avoid delays in retrieving data from the disk storage. What are analytical platforms? These are high-speed platforms using both relational and non-relational tools optimized for large data sets. Right, so you're analyzing the data. So it's using both relational and non-relational tools for large data sets. So just know that the tools for improving business performance, analytical platforms in computing, in-memory computing, Hadoop. Alright, so let's progress. Another session again. We'll talk about it. So the analytical tools, we are continuing the analytical tools, the relationships, patterns, and trends. So that's what the the analytical platforms are and do right. So with the let's marketing, right, analytical platforms, and you have analytical tools. These tools are used on the analytical platforms to what? Determine the relationship or identify relationships, patterns, and trends. Now, the tools for consolidating, analyzing, and providing access to vast amounts of data to help users make better business decisions. That's what analytical tools are, right? Tools for consolidating, analyzing, and providing access to vast amount of data, big data, to help users make better business decisions. So, how do you do this analysis? We can do data mining, you have text mining, you have web mining. There's also the multidimensional data analysis. That's the OLAP. So these are what the power users use. The power users. These are what they do, what they use. So let me make reference to that. Right. These are the power users. The power users that I'm talking about. So now you have queries, reports, OLAP, data mining, right? So here we would have web mining and text mining. So these are the power users, right? You have casual users and you have power users. Right? The power users are what? They use the sophisticated analytical tool sets, right? But the casual users use it for query and reporting tools. So as I was saying, these are the ways of making your analysis. So let's dive into that. There's the online analytical processing. That's actually what the OLAP is. I'll also written over here. So let's see where the road will take us. Right. So online analytical processing. So that supports multidimensional data analysis. Viewing data using multiple dimensions. Each aspect of information, product, pricing, cost, region, time period, is different dimension. Remember, MIS, we are talking about how to use it in business, management information system. That's why I'm seeing all the product, all the examples that I are seeing, product, price, it's all about business. Right, so each aspect of information. Now, example, how many washes sold in the East in June compared with other regions? Right, so OLAP, that's the online analytical processing, enables rapid online access to ad hoc queries. Yeah. This is a multi-dimensional data model, not both washes, schools, actual, projected, east, west, central, so region, product, projected, right? The view that is showing is product versus region. If you rotate the cube 90 degrees, then face the face that will show project versus actual and projected sales. If you rotate the cube 90 degrees again, you will see regional versus actual and projected sales. Other views are possible, right? So you get a combination of views. If you turn like this, you are seeing actual, projected, and actual. Right now, I see what's projected and regional. If you turn it the other way around, I get it. So that's what we mean by multi-dimensional. That's actually clever. And then data mining. Data mining finds hidden patterns or relationships in data sets, right? Example, customer buying patterns. Data mining also infers rules to predict future behavior, right? What we do every day is what we do every day. So we do. It's what we did yesterday. And what we did yesterday is likely what we'll do tomorrow. What shall we do today? So knowing how people behave, we will let you know how they're going to behave. Right. So that's what data mining is used for, to predict future behavior. Right. Types of information obtainable from data mining: association, sequences, classification, clustering, forecasting. Right. That's what data mining does or produces. We have text mining. Now, text mining extracts key elements from large unstructured data sets. Like, so unstructured data sets, we have stored emails, call center transcripts, legal cases, pattern descriptions, and sorry, patent description, not patent, patent descriptions, and the service reports and so on. Now, the sentiment analysis software that mines emails, blogs, social media to detect opinions. So this is what text mining does. Right? So that's how you another way of analyzing big data. Then there's web mining. Web mining has to do the discovery and analysis of user patterns and information from the web, understand customer behavior, and evaluate effectiveness of websites and so on. Right. So that's the discovery and analysis of user patterns and information from the web. Now we have web content mining. That mines content of web pages. There's web structure mining that analyzes links to and from web page. And there's the web usage mining, which mines user interaction data recorded by the web server. Right, so that's what web mining is about. You can mine web content, you can mine web structure, you can mine the web usage. Right, so mining is just like analyzing. So we have databases on the web. That's also another tool for improving business performance and decision making. So many companies use web to make some internal databases available to customers or partners. Right. So the typical configuration includes web server, application server or middleware or CGI scripts. Then the database server hosting the database management system. Right. So that's one way you can improve your performance and your decision making. You allow outsiders, external people or entities to have access to your internal databases through the web. So the advantages of doing that are there's the ease of use of browser software. The web interface requires few or no changes to the database. It's inexpensive to add web interface to the system, right? So this database and web, when you are creating it, these are the things that you use for your configuration: the web server, the application server, or middleware or CGI scripts. Then your database server. So there are three. So how do you link internal databases to the internet? This is the client with web browser. This is the internet. Web server, application server, database server, then database. Right. So this is the configuration. That I was talking about the three things: web server, application server, and database server. Let's check. Web server, application server, database server. The same. So on one extreme, you have the client to them. So this is where your customers will access it. So they'll just connect to the internet, you get to the web server, this. So database. So the users access an organization's internal base to the web using their desktop PCs and web browser software. So this is the desktop PC and the web browser software. Internet. Right. So that's it. So now last part, how do we manage the firm's data resources? One, we establish information policy. Now, information policy are the firm's rules and procedures, and rules for sharing, managing, standardizing data, right? So the information policy are the rules, procedures, and rules for sharing, managing, and standardizing data, right? It also has the data administration. Data administration, it establishes policies and procedures to manage data. Data governance, which deals with the policies and processes for managing availability, usability, integrity, and security of data, especially regarding government regulations. Now, database administration, that's creating and managing database, right? So that the information The information, the information policy does that. Right? So now data quality, right? More than 25% of critical data in Fortune 1000 company databases are inaccurate or incomplete. Incomplete, right? There is the redundant data, inconsistent data, and then 40 input. Right? So you have to ensure data quality. Now, before new database is in place, you need to identify and correct faulty data, establish better routines for editing data once database is in operation. Right, so you have to work on your data quality. You have to ensure that the data quality. That's how you manage your data resources. Right, information policy. You have the data quality. That's the data quality assurance I spoke about earlier. Data quality audit, structured survey of the accuracy and the level of completeness of data in an information system. So survey samples from data files or survey end users for assessment of quality. So data quality audit. As you are doing your quality assurance for your data, you are also interacting with the people who are using the information. Have a way of identifying or how the quality of your data is perceived, right? So you have to make your survey. So that you use survey samples from your data files or you survey end users, right? Then data cleansing. Now you also need a software to detect and correct data that are incorrect, incomplete, improperly formatted, or redundant. So you have to find a way to detect and correct your data. That's data cleansing. And also enforce consistency among different sets of data from separate information systems. So that's one aspect of it, right? So that's the entire session when we're doing. So thank you very much for watching. Please don't forget to like and subscribe. The Projects.